Everybody. In this video, we're going to talk a little bit more about similar figures and similar triangles. So just to review, similar polygons are polygons with the same shape but different sizes. Let me write that down here. Same shape but different sizes. Polygons are similar if corresponding angles are congruent. Corresponding angles are congruent, and if corresponding sides are proportional. The ratio of corresponding sides is called the scale factor. And if polygons are similar, then something to keep in mind, their perimeters are also proportional. And that makes sense because the side lanes are proportional and you find perimeters by adding up the side lanes of any polygon. So if the sides are proportional, then the perimeters will also be proportional. Let's talk a little bit more about scale factor. So it says here, what is the scale factor of triangle ABC to triangle DEF? So just remember to find the scale factor, we take a side from big triangle and divide it by a side from small triangle. But here in the first one, it is saying of triangle ABC to triangle DEF. Triangle ABC does happen to be the smaller one here. So they're asking um, the scale factor in both ways here, from small to big triangle and then from big to small triangle. So from small to big triangle, let me take a side from triangle ABC. I'll just take the side labeled 8. And I'm going to divide by the corresponding side on triangle DEF 12. And I find that my scale factor is 2/3 in simplest form. Normally, when we find scale factor, we take a side of big triangle and divide by the corresponding side from small triangle. So here it's asking for the scale factor of big triangle DEF to small triangle ABC. I'll take the side 12, once again, on big triangle, and that corresponds to the side labeled 8 on the small triangle, and that reduces to 3/2. So 3/2 is what we would multiply each side of the small triangle by to get to the corresponding side of the big triangle. The reverse way, 2/3 is what we would divide each side of the big triangle by to get to the corresponding side of the small triangle. And here it says, what is the ratio of the perimeter of triangle DEF to triangle ABC? So it would be the same thing. It would be 3/2. And you can see that if you add up all the side lanes of the small triangle, 8 plus 10 plus 14, that's 32. And if you add up all the sides of the big triangle, 12 plus 21 plus 15, that's 48. And if I take 48, the perimeter of the big triangle, and divide by 32, which is the perimeter of the small triangle, that should reduce to 3/2. So let's talk about similarity statements now. So the symbol for similar is this little squiggle over here. And a valid similarity statement must match corresponding angles and sides. So it's asking us to write a similarity statement for the triangles above that we just found the scale factor and the ratio of the perimeters for. So that would be triangle. If I'm starting with ABC on the small triangle, I'm going to have to keep corresponding parts together on the big triangle. A corresponds to D, B corresponds to E, and C corresponds to F. And there we have our similarity statement. Triangle ABC is similar to triangle DEF. On the bottom here, it says list all congruent angles. and write a proportion that relates the corresponding sides. So the congruent angles here would be angle J, and that corresponds. Angle J is the first letter in the name JKL, so it would correspond to the first letter in the name of triangle PMN, which is P. So angle J corresponds to angle P. So angle J would be congruent to angle P. Angle K, second letter, corresponds to the second letter, which is angle M. So let me write that here. Angle K is congruent to angle M. And once again, this is true because the two triangles are similar to each other. So that means the corresponding angles are congruent to each other. And finally, angle L, which is the third letter in the name, corresponds to angle N, which is the third letter in the name of this triangle. So remember, triangles are named with their corresponding parts in order. So if you're in doubt or not really sure about what corresponds to what, the sides or the angles, you can take a look at the naming of the triangles. And let's talk about the sides. So JK, first and second letters, that would correspond to PM. PM, first and second letters on this triangle. So let me write that here. JK is proportional to PM, because remember, when we have similar triangles, corresponding parts are proportional. And what that means is they have the same ratio. So let me not confuse anybody. I'm not going to put that symbol because that means the congruent symbol, and they're not congruent, they're proportional. Instead, I will just put it as a ratio over here. JK is proportional to PM because they are corresponding sides of the similar triangles. KL, second and third letters of this triangle name, which would correspond to MN, second and third letters of this triangle name. So let me write that down. KL should correspond to MN, so they would be proportional. And finally, the last side is JL, and that's the first and third letters, so it would correspond to PN. So those would be proportional since these are similar triangles. And we're able to put all these ratios equal to each other because remember, in similar triangles, the corresponding sides are all proportional by the same scale factor. Um, they can't have different scale factors. It's not like one pair of corresponding sides can have a different scale factor than another pair of corresponding sides. If the triangles are similar, all three pairs of corresponding sides will be proportional by the same scale factor. You'll be multiplying by the same number to get from each of the sides on the smaller triangle to the corresponding sides on the larger triangle. Okay, let's move it along. Here we're going to continue and we are going to do the same thing. We are going to name some congruent angles in the similar triangles, and we're going to name the proportional sides. So here we have triangle XYZ, the large triangle, similar to triangle RYS, which is the smaller triangle over here. So the congruent angles, angle Y in this triangle is congruent to angle Y in this triangle because they do correspond. They are the same angle in both of the triangles. Angle R is the first letter here, so that would correspond to angle X. So angle R is congruent to angle X. And finally, angle Z, third letter, would be congruent to angle S. And for the sides, on the small triangle, RY, first and second letters, would be proportional to the first and second letters on this triangle's name, which would be XY. YS, second and third letters, would be proportional to YZ, second and third letters. And finally, RS would be proportional to XZ. Take a second and write a similarity statement for the next one. list all of the congruent pairs of corresponding angles, and write a ratio relating the proportional sides together. You can take a second and you can check your work and make sure that you have the correct angles listed together as congruent and that you have the corresponding sides labeled as proportional to each other in your ratios. Since corresponding sides of similar triangles are proportional, we can set up proportions to find missing side lengths, so we're going to practice that now. So in number 4 over here, it says, if the figures below are similar with a scale factor of 2 to 3, find the value of x. So I'm just going to write my ratio of 2 to 3 in fraction form. So 2 over 3 is my scale factor over here. And I know that aside from the small triangle is 42. And the corresponding side from the big triangle is x. So using the scale factor, I can set up a proportion using the side from the small triangle, small rectangle, I should say, small quadrilateral. We're not sure it's a rectangle. We're using a side from the small quadrilateral and the corresponding side from the large quadrilateral. Now that I have a proportion, all that I have to do is cross multiply and solve for x. So we have 2 times x, which is 2x, is equal to 42 times 3, which is 126. Dividing by 2 on both sides, x is equal to 63. And if you wanted to check your work, if you multiply the 63 by 2/3, you should get 42. So that way you can check your work and make sure that it is correct. Okay, for number 5, we have 2 triangles here, and we know that the scale factor is a 6 to 5 ratio. So I'm going to do the same thing, and I'm going to write the scale factor as a fraction, 6 over 5 instead of 6 to 5. It's the same thing. And this time, the bigger number, the 6, is on the top of the ratio. So I'm going to want to start the other side of my proportion with the side from the big triangle over here. Once again, bigger numbers on top here. I'm going to want the side from the big triangle over here, which is x. And the corresponding side to x, it looks like the bottom of the triangle here, would be the bottom of the triangle over here, which is 28. Now that I have a proportion, once again, all I need to do is cross multiply and solve for x. 6 times 28 is 168, equals to 5 times x, which is 5x. Dividing by 168 on both sides, x is 33.6 if you put that into your calculator. Take a second and use a proportion to find the value of x in 6 and 7. So just like we talked about in class, if we have information about 2 pairs of corresponding sides in the figures that we're talking about that are similar, we can set up a proportion as follows. I like to set up my proportions with a side from the small triangle over a side from the corresponding side from the big triangle. So I put 25 here from side DE, and then I put the corresponding side from the big triangle AB on the bottom. On the other side of my proportion, I put another side from the small triangle and the corresponding side to that one from the big triangle underneath. Cross multiplying and solving the equation, you should get x is equal to 35. I set up the proportion here for this quadrilateral using the same idea. Aside from the small quadrilateral over the corresponding side from the big quadrilateral, a second side from the small quadrilateral over the corresponding side to it from the big quadrilateral. Cross multiplying and solving for x, we get x is equal to 60. We're going to really briefly talk in the video also about ways to prove triangles similar. And this is something that is in your packet as well, so you can take a look at this one. So we have 3 different methods of proving triangles similar. We have angle-angle similarity, which means that if you have 2 congruent corresponding angles in your 2 triangles, then that means that the third angle is also congruent making the triangles similar to each other. So number one, it says determine if the examples below are similar by AA. If yes, write a similarity statement. So I see here there are two pairs of congruent corresponding angles. So they definitely are similar by AA. In the second example, we have one pair and also we have congruent vertical angles. So we do have two triangles that are similar by AA. Our second way of proving triangle similar is SSS, or side similarity. That means if all of the corresponding sides are proportional by the same scale factor, then the triangles are similar to each other. Using number 3 over here, if I take a side from big triangle 6 over corresponding side from small triangle 3, and I take a side from big triangle, let's go with 8, over the corresponding side from small triangle 4. And then finally, the last side from the big triangle 10 over its corresponding side from small triangle 4. All of these scale factors should be the same, showing that all of the triangles are proportional, making them similar by SSS. All of these are the same. These are all 2. So I'm going to write yes. These two triangles are similar by SSS because all 3 pairs of corresponding sides are proportional by the same scale factor. And finally, let's do number 5 over here. SAS, or side angle side similarity, means 2 pairs of proportional sides with a corresponding congruent angle in between. So if we take a look over here, we do have a congruent angle in between. We just need to verify that the sides are proportional by the same scale factor. So if I take a side from the big triangle, let's go with 8 first, and its corresponding side would be 6. And I also take the other side from the big triangle, 20, over its corresponding side from the small triangle. These are the same. If you put these into your calculator, 8 over 6 and 20 over 15 will give you the same value. So the answer is yes. These two triangles are similar by SAS because we have 2 pairs of proportional corresponding sides with a congruent angle in between.